Hello, I'm going to be talking about radicals today. I am not talking about progressive politics or like a surfer dude, I am talking about mathematics. So we're going to be looking at equations that have just one radical in them, and when you're solving for x underneath that radical, how do you get that x out of there? How do you deal with that? I just want my x out of this cage. Also, if you hear any strange whirring in the background, do not be worried. It is just the cicadas. It is the year of the cicadas around here. They only hatch once every 17 years, so soak it in. That is a cicada. Radicals as in taking a cube root of a number or a square root of a number. What kind of root? A cube root of a number or a square root of a number. Cube roots or square roots. Alright everybody, assumptions. So when we don't see any number on the outside of the radical indicating what nth root we're taking it to, we're going to assume we're taking the square root of the number. So we're going to pretend when there's no number there, like there's a little 2 on the outside of that radical sign. The second assumption that we're going to be making is that they're asking only for the principal root of the square root unless they tell us otherwise. The principal root is just the positive square root. So when we take a square root, like of 25, we can get positive 5 or negative 5. In this situation, when we're gonna only take the positive 5, the negative 5 is just as important and just as valid. They're just not asking for it, so assume that they're only asking for the positive square root. So we've gotten our couple assumptions taken care of. Consider yourself in the loop. Okay, we're gonna look at solving an equation. Here we go, here we go. Let's start with the equation negative 4 plus the square root of x plus 10 is equal to x. The first thing that we want to do is isolate the radical on one side of the equation. So we're going to add 4 to both sides. Now that we have the radical isolated on one side of the equation, we're going to square both sides of the equation to get rid of it. You want to isolate the radical on one side of the equation first, because if you square the sides of the equation before you do that, you're going to end up with a crazy big mess. So isolate the radical, isolate it, isolate it. A reminder, you cannot take the sum of things under a radical and just make it the sum of 2 radicals. Does not work. You can do that with multiplication, you cannot do it with addition. No es bueno, don't do it. So we square both sides of the equation and end up with x plus 10 is equal to x plus 4 times x plus 4. We're going to end up with these solutions called extraneous solutions. So right here is where the extraneous solution comes in. When we square both sides of the equation, we end up with this, but that same equation would be the result even if this was negative square root of x plus 10. Because squaring it will still end up with the positive x plus 10 on here. We'll deal with that in a little bit. Once we get the equation in this form, it looks more familiar. It's got that whole quadratic thing going on. So we're going to subtract x from both sides of the equation and subtract 10 from both sides of the equation. Minus x minus 10. And combine like terms. That leaves us with this very pretty equation. 0 is equal to x squared plus 7x plus 6. So once we have our equation in quadratic form, we can do the whole reverse FOIL thing, which leaves us with 0 is equal to x plus 1 times x plus 6, giving us the solutions x is equal to negative 1 or x is equal to negative 6. If you prefer using the quadratic equation, go for it. So we have these two solutions. They're both possible solutions. We have to plug them back into the original equation to make sure we're not dealing with any extraneous solutions. All right, so let's plug the first one back into the solution. First possible solution, negative 1. All right, let's see how it turns out. Is this a solution? Okay, so we've got negative 4 plus the square root of 9 is equal to negative 1. Again, we're only using the positive square roots in these situations. So this positive square root of 9 is 3, which leaves us with negative 4 plus 3 is equal to negative 1, which leaves us with negative 1 is equal to 1. Checks out! Negative 1 is the solution! Now, let's do the same thing for negative 6. Is this a possible solution? Are they going to equal each other? we end up with negative 4 plus the square root of 4 is equal to negative 6, which gives us negative 4 plus 2 is equal to negative 6, which gives us negative 2 is equal to negative 6, which is just not true. Therefore, negative 6 is an extraneous solution. We can't use it with a solution that will fit this equation. If we had a negative here instead of a positive, if it was minus the radical, because that would give us negative 4 minus 2, which would give us the negative 6. So for our final solution, we discard the negative 6 and only use the negative 1. So recap, when you have one radical in an equation and you're trying to solve for x underneath that radical, isolate the radical on one side of the equation, square both sides of the equation, and solve for x like you normally would. Plug your solutions back in at the end to make sure you rule out any extraneous solutions. Get them out of there. And then you're good. And there you have it. Radicals aren't so scary anymore. Okay, everybody, if you have any comments, feel free to leave them below. I'm sure you're all chock full of good ideas.